Hello and good day, everyone. My name is Lucas Dinhof. I'm international cybersecurity and AI consultant, and I welcome you to an interesting scientific project. Today's presentation focuses on scientific project titled Deep CNN WatchGuard 1.0 Development and Laboratory Experiment of Convolutional Neural Networks with Variation Characteristics for Advanced Cybersecurity Analysis. So, what's coming up? First of all, I want to provide you with a clear path through this research. The research begins by clearly defining the problem, creating a structured approach for scientific exploration. Next, the fundamentals of convolutional neural networks are explained to build also a solid understanding of this topic. A review of existing studies placed this research with the broader field of deep learning in cybersecurity area. The methodology is carefully designed to ensure accurate evaluation using quantitative matrix and statistical tests. Also, the implementation phase focuses on optimizing the model and fine-tuning hyperparameters for better performance. The results are analyzed by comparing CNN models with randomized ones. Also, t-tests are applied to verify statistical significance, ensuring reliable findings. The discussion also explores how CNN structures impact performance, considering biases and limitations. Finally, the study concludes with key insights in future research directions. Fundamental problem arises from the following circumstances overall. First, malware threats, especially ransomware, are becoming more frequent and complex, posing challenges both in the EU and national states levels. But furthermore, at the same time, AI-driven cybersecurity solutions are in high demand. Organizations also are adapting machine learning and deep learning to improve threat automation and cyber resilience. CNN-based deep learning models have proven highly effective in pattern recognition, anomaly detection, and real-time threat classification. The objectives of this following study are that first of all, this study is based on one main research questions and three sub-questions, focuses on the exploration and development of CNN models and architectures. It also examines both standard CNN architectures, for example, AlexNet, VGGNet, and LeNet5, and also randomized models where parameters and also hyperparameters are modified through random selection. This study also ensures a structured classification and performance evaluation within its framework. The main goal is to optimize CNN models and achieve highly significant results, contributing to both theoretical advancements and practical applications in deep learning-based cybersecurity. This study also explores fundamental concepts to build a strong research foundation. There are distinctions between IT security, cybersecurity, and information security. Overall, IT security focuses on protecting computer systems and networks. Cybersecurity deals with defending against threats like malware, ransomware, and hacking. The third term, information security, covers broader aspects like data protection, privacy, and legal compliance. Also, the thick Mailman 2020 dataset from the University of New Brunswick in Canada should be explained. This dataset consists of malware memory dumps, making it ideal for training and testing deep learning models for malicious software detection. So what are convolutional neural networks? In general, you can say these models, architectures are deep forward networks, and they are very good in pattern recognition. While widely used in image processing, they also play a key role in cybersecurity by identifying malware patterns in data more and more. There is also a distinction between classification and regression in machine learning, but also deep learning. First, classification models categorize data into specific groups, for example, malware versus benign software. Second, regression models predict continuous values, such as the severity of an attack. In this study, we have also important standard models, which are predefined CNN architectures like LeNet 5, AlexNet, and VGGNet serve as benchmark models for malware classification in this study. We can also find, moreover, randomized models. These models undergo random variations in parameters like filter sizes, learning rates, and also activation functions, enabling a broader performance analysis. There are also quantitative performance matrix, which are actually a matrix like accuracy, precision, recall, and F1 score, and also qualitative matrix evaluate transparency, explainability, and robustness, considering ethical and legal compliance for like the EU AI Act. This study has only included peer review sources. It includes only high quality peer reviewed research, excluding non-trusted transparent or unreliable studies. Publication from the 1st of January 2022 and the end of January 24 were analyzed using strategically refined search terms to focus on CNN-based cybersecurity research. There were only chosen studies based on high quality and relevance, ensuring only scientifically sound research was included. Moreover, there are two key research areas. Part 1 consists of the role of CNNs in cybersecurity. Part 2 focuses on the analysis of studies using this specific SIG Mailman 22 dataset. The result is that we have a total of 15 peer-reviewed studies which were selected to form a solid understanding for this research. This research design follows overall a quantitative study approach from the perspective of data science, but also IT and cybersecurity. Additionally, there are also overlaps with classical laboratory experiments incorporating observations and control evaluations. A hypothesis test is conducted using p-values with the standardized alpha level set of 5%. Qualitative criteria such as objectivity, reliability, and validity must be ensured, along with ethical consideration, transparency, and reproducibility. A key aspect of the study is also the development of original theses and new insights. As applied research methods and planning instruments, three different approaches were used. First, a flow chart, which you can see on the left top. Second, a use case diagram on the right, and on the bottom you can see a general overview of the CNN architecture. Moreover, several program libraries in Python, such as TensorFlow, Keras, and Number, were used for implementation. To prepare the datasets for deep learning models, various pre-processing techniques are applied. This includes the column transformer, which allows for efficient feature transformation, the min-max scaler, and one-hot encoding to convert categorical variables into a machine-readable format. To optimize model performance, hyperparameters are randomly selected, allowing for wide range of configurations to be tested. This includes variations in the numbers of filters, learning rate, kernel size, but also drop-up rate and additional layers, batch size, optimizer choice, and deactivation function. The goal overall in this case is to identify the most effective parameter combinations for improving CNN performance. The results in the studies are very good. The results for binary classifications show that the standard models LeNet5 and AlexNet achieve perfect accuracy, while VGGNet produced suboptimal and unacceptable rates. which you can see on the left side. For the overall classification, which is on the right side, with 112 different classes, overall accuracy, precision, and recall decreased significantly. However, the first two models, LeNet 5 and AlexNet, still delivered reasonable and acceptable performance, demonstrating their robustness even with increased complexity. Furthermore, the results also showed strong performance for the random models in overall classification, with an excellent ROC-OR curve, as well as well-structured training and validation curves. I also observed outstanding results for the random models for in-binary classification, as shown on the right. Also, the t-test reveals highly significant differences in both standard and random conditions, based on the null and alternative hypothesis. Specific modifications in the architecture of CNNs have a strong impact on accuracy and the F1 score when compared to standard CNNs. Also, the results show highly significant differences between binary and multi-class classification. Increasing the number of classes leads to lower performance in general. The models LeNet 5 and AlexNet achieve better results than VGGNet in terms of accuracy and efficiency. The choice of hyperparameters plays also a crucial role, as it can significantly influence key quantitative metrics. Transparency in model development is ensured through detailed documentation and strict adherence to ethical and legal guidelines such as the EU AI Act. This research also contributes to the optimization of the current state of knowledge by providing quantitative metrics. The advancements in insights and novel approaches create potential for patents and corporate applications. Scaling the models and minimizing biases remain significant challenges that need to be also addressed. The benefits of this research are twofold, and as it enhances both security and competitive advantages. We can also find some limitations. The research has limitations in dataset selection, model scope, while also facing challenges in data representation. This research is also limited to a specific datasets, which may the results. The study focuses on the expansion of synthetic data. Another disadvantage is that there's no comparison group that includes other deep learning architectures such as LSTM or GAN, which could provide additional insights. The publication of the source code increases transparency but does not offer protection against industrial espionage. Now, from this point, we can say that future research in this case could focus on further developing hypotheses, especially in the areas of LSTM and parameter optimization. The study could also investigate the robustness of AI algorithms against cyber attacks. Expert feedback could also be possible, which will be incorporated to enhance model performance. Further studies could also focus on energy consumptions during training process, which will be measured to assess computational efficiency. In summary, this research provides valuable insights and opens new opportunities for further exploration. Thank you for the time and see you next time.